Hello, this is Shankar from System-Based Labs. I've worked across regulated environments and medical imaging platforms, and I'd like to share some insights. Today, let's clearly understand how IQ, OQ, and PQ apply to machine learning systems. Let's start with the foundation. In traditional system validation, we follow a well-established structure. Installation qualification, or IQ, ensures that the system is installed correctly in the intended environment. This includes verifying software installation, infrastructure setup, configurations, and dependencies. In simple terms, is the system set up correctly? Next is operational qualification, or OQ. OQ ensures that the system operates according to defined specifications under controlled conditions. Here, we test functionality, expected outputs, and boundary conditions. So the question becomes, does the system work as designed? Then comes performance qualification, or PQ. PQ ensures that the system performs consistently in real-world conditions. This includes actual user workflows, real data, and operational variability. So now we ask, does the system work reliably in real life? Now this model works very well for traditional systems, because traditional systems are deterministic, same input, same output. Logic is predefined. Validation is about verifying expected behavior. But when we move into machine learning systems, things change. Machine learning models are not rule-based. They are data-driven. Their behavior is learned, not explicitly programmed. So we don't discard IQ, OQ, and PQ. We adapt them. Let's translate this into the ML world. IQ and ML becomes validation of the deployment environment. We verify that the correct model version is deployed. We check infrastructure, servers, GPUs, libraries, and dependencies. We validate data pipelines, how data is ingested, processed, and passed to the model. Because if the environment is wrong, the model behavior is affected. So here, IQ becomes, is the ML system set up correctly? Now OQ. In ML systems, OQ is no longer about fixed outputs. It becomes validation of dataset integrity and model behavior under controlled conditions. We verify training and test dataset separation, labeling accuracy, data completeness, and representativeness. And we evaluate how the model behaves on known labeled datasets. So now OQ becomes, does the model behave as expected under controlled data conditions? Now PQ, this is where ML validation becomes critical. PQ and ML focuses on real-world performance. We evaluate sensitivity, specificity, ROC-AUCm, and performance across different populations. And we ensure the model integrates correctly into clinical workflows. Because a model that works in testing but fails in real-world usage is a real risk. So PQ becomes, does the model perform reliably in real-world clinical scenarios? Now here's the important shift. Machine learning introduces something new, continuous validation. In traditional systems, once IQ, OQ, and PQ are complete, the system is validated. Revalidation happens only when changes occur. But in ML systems, even without explicit changes, performance can degrade. Why? Because data changes, data evolves, new patterns emerge. This leads to model drift. So validation is no longer a one-time activity. It becomes an ongoing process. We monitor performance continuously. We compare real-world metrics against validation baselines. We detect drift, and we trigger revalidation when needed. So we add a new layer. Is the model still valid today? That's the real difference. Let's summarize this clearly. Traditional validation. IQ, is it installed correctly? OQ, does it work as designed? PQ, does it work in real life? ML validation, environment validation, dataset and behavior validation, performance and clinical validation, and continuous monitoring. So the structure remains, but the thinking evolves, and that evolution is important because in machine learning, we are not just validating logic, we are validating behavior over time. Let me leave you with this. IQ, OQ, and PQ validate system setup, behavior, and performance. Machine learning validation adds data integrity and continuous monitoring on top of that. This is Shankar from System-Based Labs. I'll see you in the next training session. Wish you good luck and goodbye.